Today's topic is on VPC. VPC stands for Virtual Port Channel. So, what is Virtual Port Channel? This is actually a layer 2 Nexus technology where when you configure VPC between two Nexus switches, so let's assume I have two Nexus switches between which I'm going to be configuring a VPC domain. These two switches logically appear as one to whatever devices are connected in the downstream. All right. VPC, please make note, is a layer 2 Nexus technology where when you configure VPC configurations between these two Nexus switches, they logically appear as a single switch to your downstream device. Whatever is your downstream device, the downstream device will only see a single logical switch that it is connected to. It would never know that there are two switches which are connected to its uplink. All right. Now, before we move to VPC, let's have a quick recap on port channeling. So, first is what is port channel? Port channel or is also called as ether channel. This is nothing but this is nothing but where you are aggregating your multiple links, right? Why are you even aggregating them into a single bundle? That is because of STP. So it all started from STP. STP is where you are avoiding your loops in a layer 2 environment. So STP only runs between the multiple switches. This is a layer 2 loop avoidance mechanism. According to this particular algorithm, when there are multiple links, so let's just take a very simple diagram. Let's take I have A and B devices. If there is one link, then STP will not come into picture because there's only one link, no loop will happen in this, right? But if there is at least two links or more than two links like this between the two devices, then what happens is only one link is going to be forwarded, the remaining are all going to be in a blocking state, right? So disadvantage over here is that definitely you're not going to be utilizing all of the available bandwidth, right? So this is where port channeling or ether channel came into picture, where what you could do is how many ever links were there between two devices, you could aggregate them into a port channel where that port channel would logically appear as a single link. Okay, so all of your physical links inside that particular bundle will be active at all times. So your port channel will be up as long as even one. You have the advantage of link level redundancy here. Even if one link goes down, it does not matter. You still have the other links, and your port channel is still going to be up, right? So you're going to be utilizing the full bandwidth also over here. But limitation of port channel is that whenever you're aggregating these links, the port channel can be created only between these two devices. Like for example, A and B. These are two devices, and only between them I can aggregate them. I can aggregate these links into a port channel. I cannot have a scenario where I have A, B, and C, where A is connected to both B and C, and I have a port channel connection like this. This is not supported in a traditional port channel environment, right? So limitation of port channel is that you can only have or you can only aggregate links into a single bundle as long as it is connected to one other device, not to multiple devices like this. All right. Now, for configuring port channel, again, there are different ways. Dynamically, you can configure port channels using certain protocols like LACP and PAGP. What is LACP? LACP over here is Link Aggregation Control Protocol, which is definitely open standard. And PAGP is Port Aggregation Protocol, which is definitely Cisco proprietary. So even though this is Cisco proprietary, not a lot of devices from Cisco themselves support this particular protocol. All right, like Nexus switches, they can only be configured with LACP or even static configuration. It does not matter. Like in PAGP is not used on Nexus switches. Now again, whenever you're using these multiple modes, so let's say I am configuring a port channel between A and B. All right. When I'm configuring a port channel between A and B, I can configure certain modes for these interfaces. When you're using LACP, there are two modes that you have. One is called as active, the other one is called as standby. Sorry, passive. Right? In PAGP again, you have similar modes of your interfaces. One is called as auto and the other one is called as desirable. Now the question is, what is active? If I am configuring an interface under the LACP active mode, what does that mean? So please do make note and please do remember, whichever interface is configured as the active, the port on that particular box is going to be initiating the conversation or the negotiation first. What kind of negotiation? So whenever you are aggregating these multiple links into a port channel, what happens is there are certain interface level configurations which are exchanged to make sure that they are consistent across both sides. Interface level configurations like, for example, the speed of that particular interface, it could be the MTU, it could be um, anything, it could be the like a full duplex or a half duplex or an auto negotiation, whatever it is, all of these are certain parameters. The LACP timers, there are certain parameters which are exchanged across both the devices to make sure that these configurations are consistent. All right, and only if they are consistent, those ports will be aggregated or those links will be aggregated into a port channel to logically appear as one. So here, whichever interface it is that I have configured as active is the first one to initiate that particular negotiation. The first one to initiate that particular conversation so that they can start exchanging these different parameters. Opposite is passive. Whichever port it is that I have configured as LACP passive mode is the one who always only listens. He never initiates any conversation. This guy is only listening. Active wala is only talking. He is the one who initiates that particular negotiation. All right. So if I have configured active on one side, passive on another side, will my port channel come up? Definitely yes. Right? Because active is the one who is initiating this particular conversation. Passive is the one who is listening to that particular conversation, and then eventually he'll also exchange his parameters, but he's never going to initiate it. All right. Now, both sides, if I have configured the ports as passive, my port channel will never come up. Both of them are always listening. Nobody will initiate anything. Both of them will just keep quiet. So, port channel will never come up. All right. Now, what happens if I have configured both the ports as an active mode? Now, active means the one who initiates. Yahan pe both of them can initiate this particular conversation. So, who is the first one to initiate that particular negotiation? This scenario is firstly called as LACP active active scenario. All right. Whenever you are facing this particular scenario, then what happens is LACP priority comes into picture. So when you enable LACP protocol on each of these Nexus switches or whatever switches it is that you're using for aggregating them into a port channel using LACP, there is a priority that is assigned, and by default the priority is 32768. All right. So among the two devices, whichever device has the least LACP priority, the port on that device is the first one to initiate this particular negotiation. What if in case the priorities are the same, then the MAC address comes into picture. Whichever device has the least MAC address, the port on that device is the first one to initiate this particular negotiation. I hope everyone understood. Please make note of this. Active is the one who is always initiating the conversation, who's always initiating that particular negotiation, so they can exchange parameters to make sure that these parameters are consistent. Along with that, there's also passive mode. Whichever interface it is that I have configured as passive, he never initiates the conversation. He's always listening. All right. So if I have active on one side, passive on another, my port channel will definitely come up. If I have passive on both sides, port channel will never come up. All right. Now, if I have active, both sides configured as active, then LACP priority comes into picture. Whichever device has the least LACP priority, that device is the first one to, that port on that particular device is the first one to initiate the negotiation, and the other port will not. He will just listen. All right. Similarly, in PAGP, there is auto, there is desirable. Desirable is the same as active, the first one to initiate the negotiation. Auto is the same thing as passive, he's only listening. How many ports can be aggregated, or how many links can be aggregated into a port channel? Maximum number of links that can be aggregated into a port channel. As of now, it is maximum of 32. Out of these 32, 16 can be active. Before, yes, maximum was 16 and 8, any 8 could be active. But as of now, maximum can go up to 32, where 16 are active. But I've also heard there is a 64 um, link port channel as well. I am not extremely sure about this, but this I am sure of. So I'll check about the 64. I'm not sure about that, but this one, yes. So as of now, 32 links you can have into an aggregation, out of which any 16 will come up and be active. One more thing is, let's say, for example, with respect to the configurations, I'm only talking about LACP. Assume I have two devices A and B, and I want to configure port channel between them. E1 slash 1, 1 slash 2. Same thing this side also, 1 slash 1, 1 slash 2. Port channel 1, and on this port channel, I want to configure or allow a VLAN 10, 20, 30. All right. Now, how is it that you would initiate the conversation? Configuration. So again, there are different ways that you can do it. You can create your port channel, allow the VLANs on the port channel itself, or you can even allow the VLANs under the interface. It's up to you. So I'm just going to allow my VLANs over here under the port channel. So switch port mode trunk, switch port trunk allowed VLANs 10, 20, and 30, and you can just give a no shut over here, and then you can go under the interface level 1 slash 1 and 2, channel group 1, because your port channel ID was 1, mode, whatever mode it is that you want to configure, I'm just giving it as active, and no shut. Please do give a no shut, like I've mentioned before multiple times, whether it's a physical interface, a port channel, an SVI, loop back, whatever it is that you're configuring, please be in the habit of giving a no shut. Now, again, there are different ways that you can configure. You can allow this or these VLANs under the interface itself, or you can just do it like this. Both of them are right. All right. Please do make note of this in case you have any confusions, because you are going to be configuring a lot of port channels in future. So this will be very handy for you. So in VPC, Coming back to VPC, VPC stands for Virtual Port Channel. It's a Nexus technology where when you configure, let's say this is Nexus 1, Nexus 2 device, when you configure VPC domain between these two devices logically appear as one to a downstream device. All right. Now, one more thing is VPC overcomes that limitation of port channeling. How? Your downstream device must always be port channel connected to both of these Nexus switches that have been configured for VPC. Alright, your downstream device must mandatorily be connected to both the Nexus switches in a port channel configuration. Only then the downstream device can see N1 and N2 as a single logical switch. I hope everyone understood. VPC is a layer 2 Nexus technology where when you configure it on two Nexus switches, they logically appear as one to your downstream device. And it also overcomes that limitation of the traditional port channel, which says that you can only aggregate links between two devices, not more than that. Right here you are connecting to multiple devices, like you can connect to two devices at the same point of time and aggregate them also in a particular port channel. All right. So with VPC, definitely you have the advantage of device level redundancy. So one device goes down, the other one is still there to back you up with your traffic. How is this? How is this different from VSS? So some of you might know, you might have already worked on VSS on catalyst switches. So there is a technology called as VSS that stands for virtual switch system. Again, concept is exactly the same. Two devices configured with VSS logically appear as one to the downstream. But what is the difference? Apart from VSS supporting only on catalyst switches and VPC only supporting on Nexus switches. Apart from this, what is the major difference? So in VSS, please remember, in VSS, you have one active device and the other device which is standby. Right? So of course, standby will only come up when your active device goes down for some reason. So you basically have only one switch running. That basically means you have only one control plane that is running. Right? So I've already explained to you, every device has its own control plane, data plane, management plane. Yahan pe I have two devices, I should actually have two control planes running. But in VSS, this is the difference. In VSS, only one device will run at a time, which is the active device. All right. So whenever there is any frames that are received over here, the frames are always hashed towards the active device, never towards the standby. All right. The frames are always sent only to the active device, never to the standby device. Agar something goes wrong with this particular active device, only then the standby device comes into picture. It becomes active, the role change takes over, and all of that. So at one point of time, you only have one control plane running in VSS. All right. But in Nexus, in VPC, basically what I'm trying to say is in VPC, here is the difference. In VPC, there is no concept of active standby. Both the devices are active, both the devices can receive and send frames whenever it is required. All right. So both the devices are active, both the devices control planes are running at all times. Did everyone understand this? Both the devices can receive and can forward data as per requirement, but both of them are active at all times. One device goes down, the other one is still there to back you up. All right. But in this also, again, even though both of them are active, there are certain roles that are present for both of these, which again I will come to a little later. But please do remember, both the devices are active. Each of these devices have their own control planes running. So you definitely have two control planes in VPC. And of course, there are certain physical connections over here, which I will be speaking about in the next. All right. So you can see here there is a physical connection. Again, this has been aggregated into a port channel. So over here in this particular logical topology, you definitely don't have STP blocked ports, right? You do not require to block any of the ports present in this logical diagram. Why should you block it? There's literally no requirement for you to do that, right? So please make note, in VPC, there is complete elimination. In VPC, there is complete elimination of STP block ports. This again raises a question, is STP running in VPC? And this is an interview question, trust me. Is STP running in VPC? STP is definitely running in VPC, but it is in the back end, maybe for any failures. If in case your VPC goes down for some XYZ reason, there should be a mechanism that is going to help you with respect to the loops. Otherwise, one more scenario is maybe until and unless you are configuring your VPC domain, there should be some sort of a loop avoidance mechanism. All right. So please make note of this. STP is running in the backend for sure, but blocked ports are completely eliminated in VPC. You do not at all require it. These two devices logically appear as one. Downstream device is port channel connected to both of these devices. So there's literally one link, one logical link that is present between these two. No requirement for you to block your ports. So I have a couple
Madhuri,
of
I have
points
a
here. In
question.
case I have missed out on anything, please make note. Provides device level redundancy with faster convergence, eliminates STP blocked ports completely. It provides you a better bandwidth utilization and one of the most common technologies that you would find in a data center. So in STP, you can see here one link is always going to go into a blocking state. That is the way STP works, right? When you have multiple links, according to the STP algorithm, there is a root switch that is elected. On what basis is the root switch elected? Yes. So bridge ID is definitely yes. It is the combination of the system priority as well as the MAC address. So priority by default is 32768. Whichever device has the least priority becomes a root switch. If in case the priorities are default or if in case the priorities are the same on all the switches, then definitely whichever device has the least MAC address becomes a root switch, right? So depending on your STP algorithm, there is the forwarding ports, that is the root port or the designated port, and then you have the blocked ports. One port in this particular topology will always get blocked because it's eventually going to cause a loop if in case all of them are in forwarding state, right? Then came the concept of port channeling, and advancement of port channeling was where VPC came into picture, where this is your downstream device. What is the downstream device? We'll come to that in the terminologies, which is what we're going to be doing next. So whatever is your downstream device, mandatorily it has to be port channel connected towards both S1 as well as S2, that is towards both of your nexus switches, and these two nexus switches logically appear as one to your downstream switch. Definitely you do have load balancing over here and load sharing over here as well. Over here I have both my nexus switches active, right? Both the control planes are active at all times. So when the downstream switch or the downstream device has to send some frames towards the upstream devices, which path is chosen? Both are active. How do I choose? Depends on your hashing algorithm. All right. By default, hashing depends on the source MAC address, but you can definitely change that particular criteria. There is source IP, source MAC, destination IP, destination MAC. You can change that criteria and have it configured as per your requirements. But by default, it is source MAC. So depending on the source MAC address, the hashing algorithm takes place. Port channeling matlab hashing algorithm hoga he hoga. So again, it can get hashed towards n1, it can get hashed towards n2, it depends. All right. Now, next, moving to certain terminologies. Again, without terminologies, we cannot move ahead. Quite a lot of things that you should know. So, please do make note. Quickly, please draw this. All right. First terminology is peer device. So, what is peer device? The two nexus switches on which you will be configuring VPC is called as peer device. Okay. I've drawn 1 and 2, right? Those two switches, those are nexus switches. The two nexus switches on which you will be configuring VPC, those are called as peer device. All right. Now, with respect to the hardware, you can have 9K among whatever we have studied, 9K, 7K, 5K. Any of these devices can be configured for VPC. Apart from these, there is 6K, 5K, 5K is here, 4K, 3K as well. You can configure VPC between those devices as well. Not at all an issue. All right. So among the devices we have studied, that's why I've mentioned it over here specifically, 9,000, 7,000, 5,000. All these three families do support VPC. When you are using VPC, first thing is please be considerate about this. When you are using VPC, the two nexus switches must logically appear as one, right? Those two switches must logically appear as one. For them to logically appear as one, the way these devices work, the ability of the device, the software build of the two devices must be the same. They should be the mirror images of each other, right? Only then they can logically appear as one. If they are completely different, how can they appear as a single switch? Okay, so whenever it is that you are pairing up your devices for VPC, please firstly pair up devices that belong to the same family. All right, even when you're pairing it up within the same family, you cannot pair them up between the different series. For example, 9,000, you have two series, 9500, 9300. Can you use 9500 as one peer device, 9300 as the second peer device? No. Why? Software builds, software foundations of both the series are completely different. The NXOS versions, the compatibility of these devices, the working of these devices are completely different. So you cannot have them configured in a VPC. All right. What about 9500 and a 9500? Definitely yes. So 9595 you can pair it up. Does not matter what hardware model. So if you remember 9500, these are modular switches. Usme there were three hardware devices, 9504, 9508, 9516. Right? So you can pair any of these hardware devices with each other, it does not matter. You can have a 9504 and 9516 paired together for VPC, it does not matter, it will work. Alright, similarly, 9300 paired up with another 9300 will definitely work. Same thing with 5K devices as well. 5K family has two series, 5500, 5600. The device capabilities are completely different, and along with that, their software base, the software foundation is completely different. All right, so these two cannot be paired up with each other. You can pair up a 5500 with a 5500 device, 5600 with another 5600 device. Hardware model does not matter. 5548 you can pair with a 5596. It's completely okay. Similarly, 5600 with another 5600. The device does not matter as long as they're belonging to the same series. All right. What about 7K? So 7K has 7000 as well as 7700 series. Only for 7K, you can definitely pair the two series with each other. Why? Because when we started 7K, I had clearly mentioned to you the working of both the devices, the software builds of both the devices, the compatibility of both these devices, completely the same. The only difference is with respect to the port capabilities. 7000 can handle up to 100 gig, 77 can have up to 100 gig ports, 7000 can handle up to 40 gig. This is literally the only difference. Okay? But apart from that, the working, the way these switches, like receive the frames, process those frames, route those particular packets, the software builds, everything is the same. So you can pair these two series up. This is the only exception. For the other switches, again, you need to make sure that they're belonging to the same series. Any hardware model is fine. All right. So this is a pure device. Please make note. Terminology is VPC domain. So what is VPC domain? When you configure VPC on both of these devices, there is something called as VPC domain that comes up. All right, it comes up. Once the VPC domain comes up, that is when these two physically different devices logically appear as a single switch. Did everyone understand? When you configure VPC on both of these switches, there are certain configurations that you have to do, which we will be discussing as we move ahead. So, when you configure these two switches for VPC, the domain comes up after certain parameters are exchanged. Again, there is an exchange of parameters to make sure that they are actually the mirror images of each other. To make sure that certain configurations are consistent on both of these devices, which we will be discussing. All right. So, when your VPC domain comes up, that is when these two devices logically appear as a single switch to your downstream device. Okay. Every single VPC domain. So over here, when you configure VPC on switch number 1, when you configure VPC on pure device 2, there is one VPC domain that is configured, right? This one VPC domain comes up, and after that, these two switches logically appear as one. So every single VPC domain must be associated with its own domain ID. Did everyone understand? Every single VPC domain, if I'm configuring VPC between these two devices, two pure devices, they form one domain, one VPC domain. That VPC domain must be given its own domain ID. To give the domain ID, the range is from 1 to 1000. And this is mandatory. You have to give it. Okay, when you start off your configurations for VPC, you will be starting off the configuration by giving the domain ID itself. This is the first line of command that you will be giving. Okay, so if I'm giving, let's say, VPC domain ID of 10, the 10 wala domain ID has to be configured on both the devices. What if I configure domain ID 10 on one device, domain ID 20 on another device? Your domain will not come up. Okay, so for the domain to come up, please make sure that on both of these pure devices, you are configuring the same domain ID. This is one of those parameters which is definitely exchanged between the two pure devices. Did everybody understand this? Yes, when you configure VPC between two peer devices, configure domain ID. The domain ID must be the same, otherwise, your VPC domain will not come up. Only after the VPC domain comes up and is active, that is when these two switches logically appear as one. Did everyone understand? Now, can I have multiple VPC domains in my layer 2 network? Definitely. You can have multiple layer 2 domains in your, sorry, you can have multiple VPC domains in your layer 2 network. Not at all an issue. But when you have multiple VPC domains, right? I have these two peer switches again. When you have multiple VPC domains, please make sure that each of these VPC domains are configured with a unique domain ID. They both must be unique. How many other VPC domains you have in your same layer 2 network, please make sure that the domain IDs are completely different. Why? Depending on the domain ID, there is a MAC address that gets generated. About the MAC address, I'll speak later, but there is a MAC address, a virtual MAC address that gets generated depending on the domain ID. Okay, now if in case you are assigning the same domain ID, that means that there is a conflict of the MAC address. Okay, so there's going to be a lot of issues in your network. So please make sure whenever you're configuring multiple VPC domains, each of them have their own unique domain ID so that there is no conflict of this MAC address. All right. Now, again, you could ask me what happens if I have two data centers and I have configured VPC domain between them. Can I keep it different, or should I still keep it, different, or can I keep it the same, the domain ID? It depends. If in case these two data centers are communicating with each other, please make sure VPC domains are kept different. If in case they're completely isolated, one data center does not at all communicate with the other data center, then yes, you can keep it the same. Does not matter. The same thing in your layer 2 also. If in case you have like multiple pods, multiple devices, where one layer 2 network is not at all communicating with another layer 2 network, then yes, you don't have to keep them different, you can go ahead and keep them the same. But if they are somehow communicating with each other, please make sure that the IDs are completely different. Okay. Now, one more thing about VPC is, last thing about the VPC domain is the limitation of VPC. So over here, what is the limitation of VPC? Limitation of VPC is you cannot have more than two peer devices in one VPC domain. Everyone understood? Limitation is you cannot have more than two devices in one VPC domain. Only two devices can be configured for VPC, and only these two devices can logically appear as a single switch. To overcome this, that was when, if you have heard of it, fabric path had come into picture. You don't have fabric path in this version, but yeah, we were teaching this in the old one in version 2.0. In fabric path, again, fabric path is it follows the two-tier architecture where you have the concept of spine and leaves. You could have multiple spines, multiple leaves. How many ever spines and leaves you had, they all appeared logically as a single switch. But यहाँ पे in VPC, at the max, you can have two peer devices, not more than that. Also, talking about the peer device. If in case now over here, I have configured peer device 1 and peer device 2 for VPC, right? These two devices are in a VPC domain over here. Can I have a third device have the same set of connections over here and configure VPC like this? It is not supported. The rule says one nexus switch or one peer device, rather, one peer device can only be a part of one VPC domain at a time. Peer device 2 is already in a VPC domain with peer device 1. Let's say VPC domain was 10. It's already in a VPC domain with peer device 1. Now you cannot attach 2 to another peer device and have VPC domain configured over here as well. This is not supported. Alright, so please make note how many ever peer devices, whether it is one, whether it is two, these two peer devices, if they are already a part of one VPC domain, they cannot be a part of multiple VPC domains.